Hi gang, this is section 3.3, number 73. We are going to find the equation of the tangent line of this function at this specific point, okay? So this is a particular function. At this point on the function, we're going to find the corresponding tangent line. So the tangent line, whatever form you have it in, this is slope-intercept. Some of you may write your answer in standard form, right? There's three different forms. You have slope-intercept, you have standard, and you have point slope, right? So point slope. All right, so I'm probably going to write it in this form. I might choose to convert it to this form. I'm just going to see how it goes. But the end result is that we're looking for the tangent line. I like starting here because if you notice, for the tangent line, you're going to need to know the slope. And that is what the derivative gives you, right? The derivative is a slope generating function. So I'm going to start by finding the derivative. Now, since this is a variable times a variable, you're going to need to use the product rule, okay? So if you recall, and I'll use a colored marker here. The product rule is the first times the derivative of the second piece. So the first piece times the derivative of the second piece plus the second piece times the derivative of the first piece. And again, this f of x is not this f of x, okay? This could be like Fred and this is Frank, okay? These are two different f of x's. All right, so now I'll go ahead and take the product rule of this function. I may also just very quickly just remind you the derivative of e to the x is e to the x, okay? The derivative of e to the x is e to the x. Okay, so let's go ahead now and find the derivative of this function. So f of x is the x minus 1. This f of x that I'm referencing, and e to the x is the g of x. So as you see me go through the formula, I'm taking this is f of x, this is g of x. All right, so you take f of x as is, no modifications. Now you take the derivative of g of x. So I will do that in the next step. I just write out all the steps for you. So I'm in the next step going to take the derivative of the second piece. Now you leave the second piece alone. And then you take the derivative of the first piece. So then I will take the derivative of x minus 1. Okay, so in the following step, you're going to see me do that. So as we said earlier, the derivative of e to the x is e to the x. And the derivative of a linear function, so the derivative of x is 1, the derivative of a constant is what? Remember what a derivative of a constant is? Good, it's 0. So again, the derivative of x is 1, the derivative of a constant is 0, so this is going to come out as a 1, because again, the derivative of x is 1, and the derivative of a constant is 0. So all you're going to be left with is a 1. Now there's two ways to simplify this. I'm still on the simplifying stage. One way is to factor out the e to the x. If you factor out the e to the x, you have the x minus 1 left from the front term, and when you factor out an e to the x from an e to an x, make sure that you write that you have 1, right? Because e to the x divided by e to the x is 1, or to go backwards, e to the x times 1 is e to the x. And then this in here, you can see that the negative 1 and 1 go, so you're just left with x e to the x. Okay, that's one way to simplify this. The other way to simplify this, if you do not like what I just did there, is to distribute the e to the x. Okay, so part of learning is to figure out how your brain works and how it likes to think. So e to the x times e to the x is x e to the x, and then, you know, you find a way that you like to do it, and then once you find a way you like to do it, then you expand out from there. But then e to the x times negative 1 is negative 1 e to the x. Like, I learn faster if I look at something than if I hear it, but sometimes it's vice versa. I just had to learn how I learn, you know, it's part of the process. All right, so now you have negative e to the x plus e to the x. So they're equal but opposite, so they cancel, so you can see you come out with the same result. Okay, so that's the derivative. The derivative is x e to the x. Now, what we want to do is find the slope. So the slope is going to equal to f prime at the x value, which is 1. So I'm going to plug into the derivative. I'm going to let these x values be 1. So here I go. So 1 e to the 1, okay? And 1 times e to the 1 is e. So that means that the slope, what this means is the slope of the tangent line at the x value of 1 is e. That is the slope, okay? So now, let me just, I don't want to squeeze too much here. So now when you do y equals mx plus b, you now know that m is e. So what you're missing, you figured out that m is e because you found m. Now you have to find b. So now your job is to find b. Well, how do you find b? Well, to find b, you have to fill in y and x. Well, you know what y and x are because that was given. Y and x, or x and y, is 1 and 0. That was given. Right? 1 and 0 was given in the original problem. So, to find b, I let y equal 0, x equal to 1, plus b. So therefore, if I solve this, b equals to negative e. All right, so one way to write this answer is y equals ex minus e. That is one form to write the answer in, okay? That is slope-intercept. If you want to write it in standard, standard means the x and the y are on one side. Okay, so if I write it in standard, my brain wants to bring this guy to this side and this guy to this side. Not that you have to do it that way. So I'll write this more than once so I don't confuse anybody. So if I bring the e over here, and I bring the y over there, that's the signs. And now I'm just going to flip it this way. So I'm going to write e to the x minus y equals to e. Okay, that's another way to write the tangent line in standard form. And again, there's point slope. Okay, gang. So just to review, when you find the equation of a tangent line, you first find the derivative. You evaluate the derivative at the point you're looking for. Okay, and that gives you the slope of the tangent line. And then you have to go in and find your y-intercept. And then once you have all that information, I think then you can convert it to any form you want. Or you could start in point slope with your m and plug in your point, and then you could convert that also to either form. All right, that's it on this one. I hope you enjoyed the video. I'll catch you. Bye-bye.